Now in this module I want to introduce the subject of chemistry. I'm going to firstly look at what an atom is and how they combine atoms to form molecules. Now the atom is a basic unit of matter that consists of a dense central nucleus, and that is surrounded by a cloud of negative electrons, which are charged electrons. So that's got electrons surrounding it. So atoms are made up of three components, principally. You've got protons, neutrons and electrons. The protons and neutrons are in the nucleus, and the electrons are in shells surrounding the nucleus. This table here shows you the various components of an atom. Like I say, you've got protons in the nucleus, and they've got one positive charge, 1. And it's got a relative atomic mass of 1. So one proton has got a mass of 1. We call this 1, and it's located in the nucleus. A neutron in the nucleus, and that's got no charge at all, but that's got the same mass. It's got a mass of 1, and it's also located in the nucleus. An electron's got a single negative charge and a mass of 1 divided by 1836. In other words, electrons are very, very small. They've got very, very little mass. It's negligible mass compared to the neutron and proton. So when you weigh atoms, you don't take into account electrons because they're so small, they're negligible. In other words, 1,836 electrons have the same weight as 1 proton. So that table there showed you what the basic principles are and like how much they weigh, etc. Now, how are the electrons kept where they are? Well, they are attracted to the nucleus by electromagnetic force. In other words, in the nucleus, if it's got three positive charges, that is enough force to keep holding 3 electrons. So do you understand? If you've got 3 protons in the nucleus, that electromagnetic force, positive, will be able to hold 3 electrons to it. So you'll normally find if it's got 3 protons, it's got 3 electrons. If you've got 5 protons, you'll have 5 electrons. And it's this force that keeps the electrons surrounding the molecule. Likewise, a group of atoms can remain bound to each other by chemical bonds based on the same force forming the molecule, which I'll come on to later on. So it's the same principle. So a molecule is made up of a number of atoms which are bound together. Now, an atom containing an equal number of protons and electrons, as you can imagine, is electrically neutral. If it's got 5 protons and 5 electrons, it's classified as electrically neutral. Otherwise, it would be negatively or positive charge, wouldn't it? If it had 5 protons, which is 5 positives in the nucleus, and it only had 4 electrons, it would have a net positive charge, what we call an ion. Now, an atom is classified according to the number of protons and neutrons in its nucleus. Now, the number of protons determines the chemical element, so that determines what it is, the number of protons, and the number of neutrons determines the isotope of that element. So some might have so many protons but a different number of neutrons, and what you call is that will be an isotope of that element, but it's the number of protons that determine the chemical element. If you've got 3 protons, it's a certain element. If it's got 4, it's a certain element. And all elements will have a different number of protons than other elements. So what makes oxygen oxygen? Well, it's how many protons it's got in there, and if the isotope, it's how many neutrons. So that's what makes oxygen oxygen, how many protons are in there. What makes nitrogen nitrogen? Well, it's how many protons it's got in its nucleus. Now, on this planet, there's more than 100 elements, 100 different elements, and these are all listed in the periodic table. So everything on this planet is made up of molecules which contain at least one of these elements. So everything, chairs, tables, us, bodies, cars, liquids, everything is made up of one of these 100 or so elements. Everything's made up of these. Now, this is the periodic table which lists all the elements on the planet. Let's have a look at what information the periodic table can give you about the atoms. Let's look at carbon there. Out there, carbon there. Now, the bottom number is the atomic number. That bottom number there is the atomic number. And this is the number of protons in the nucleus. This is what makes carbon carbon, yeah? Because it's got a number, 6 there. So it's got 6 protons in the nucleus. So that is why it's carbon, because it's got 6 protons. Now, don't forget to be neutral. It has to have the same number of electrons orbiting it. So if it's got 6 protons, how many electrons will it have orbiting it? 6. Now, these will be arranged in different shells, but it will have 6 if it's going to be stable. 6. Now, the top number there, the top number is the mass number. And this is the number of protons and neutrons. Now, this tells you now it's 12, so that means it must have 6 protons because it's carbon, but it must also have 6 neutrons. To make a mass of 12, it's got 6 neutrons and 6 protons, and its mass is 12. 12, that's the mass number. Let's look at the atom oxygen here. This shows you the atom oxygen. Now, the atomic number of oxygen here is 8, which means it's got 8 protons in the nucleus. 8. And how many electrons will have orbiting it? 8. So whichever shell they're in, it will have 8 electrons orbiting it. Now, the mass number is 16, which means to you, not only there are 8 protons, there's also 8 neutrons in the nucleus. 8 neutrons in there. So, that's what the period tells you. It tells you the mass number and the atomic number. Now, the next thing I want to discuss is how the electrons are actually arranged. We know how many electrons are going to be in there. It'll match the number of protons. But how are they arranged? Well, what you find is there are different electron shells surrounding a nucleus. So what you have is a nucleus with loads of shells on the outside of it. Now, these shells can only hold so many electrons. So when a shell is full, it gets another shell and then another shell. Do you understand? Now, this is how they're arranged. The first shell can only hold 2 electrons. That's all it can hold, the first shell. The second shell can only hold 8 electrons. The third shell can only hold 8 electrons. The fourth shell can hold up to 18 electrons. However, generally, when it starts to get this big, you know, they're looking at the massive elements there. But generally, the first 3 are the most important. It's got 2 electrons in the first shell, 8 in the second one, and 8 in the third. How does this relate to the periodic table? Well, look here. This here shows you the first shell is the first row. That first row in the periodic table, have you noticed there's 1, 2, and that tells you that first shell can only hold 2. Basically, the rows in the periodic table match the electron shell configuration. The first row's got 2. The second row's got 8 elements. Can you see 8 elements listed there? And that will have 8 electron places to fill the shells. Do you see how it works? That's how the electron shell thing works. The next row is 8 again. It's got 8 in there. Do you see again how it works? 8. Then it's 18. Let's do an example. Let's look at an atom of oxygen. Well, the atomic number is 8. I said before, and the mass is 16. So it's got 8 protons and 8 neutrons in the nucleus. And it's also got 8 electrons orbiting it. Well, let's have a look at what it looks like then. Well, the first shell can only hold 2. We said that. And the second one can hold up to 8. But in this case, there's only 6 electrons. So as you can see, this thing it's got 2 electrons in the first shell and 6 in the other one. However, the problem is it's left 2 spaces, isn't it? It's not a full, the second shell's not full. It's got 2 spaces for electrons. That's what it's got. That's how it's arranged. So do you understand? It's got 2 places. Now this is going to come on. We're going to come on to this a bit later on about valency, about how you fill these shells, because these atoms want to fill these outer shells. They can't exist with shells that aren't full. What they have to do is share them. There's ways they can fill the shells in. And I'll come on to that later. However, let's go back to look at the periodic table again and the qualities of the various elements listed. Now, elements in group 1 here, as you can see, have got 1 electron in their outer shell. All of them have got 1 electron in the outer shell. Now, elements in group 2 have got 2 electrons in their outer shell. And elements in group 3 have got 3. Do you understand how it works? Elements in there have got 1, elements in there have got 2. Now, elements in group 0 there, that shell there, that is the full outer shell. Can you imagine if we had the 2, 8, 8, 18? These ones here are full, and these are known as the noble elements. These are full. These are full. These aren't very reactive at all, because they're full. They don't need any more electrons. They don't need to compound anything. They've actually got full outer shells. They've got full outer shells. Atoms do not want to have partially empty or partially full shells. If they've got a partially empty shell, they might get rid of an electron. If they've got a partially full shell, they want to get one. That's what they have to do. They try and combine with other atoms and either give electrons away, take electrons from other atoms, or share them. So do you understand? They're always trying to fill their outer shell. And this is why atoms combine to form molecules. Because when it becomes a molecule, what you'll find is they've all shared electrons in some form to all have full outer shells and become stable molecules. When they combine, they fill the outer shell, they become stable molecules. Let's do an example. Helium. What's the atomic number of helium? Well, it's 2, and it's got an atomic mass of 4. What does that mean? Well, it's got 2 electrons orbiting it. Well, the first shell's got 2. So as you can see, helium has got 2 protons, 2 electrons, 2 neutrons. That's what it looks like. It's full. Outer shell is full. That's why it's stable. It's an inert gas. Any atom with a full outer shell is inert. As you can see here, all these noble gases are inert because they've all got full outer shells. Neon's the next one. What's the atomic number? 10, which indicates that it's got 2 electrons in the first shell and 8 in the second shell. Well, that means it's full. The second shell is full. It's inert. It doesn't take into part chemical reactions. It's full. It wants to leave me alone. I'm actually full. I don't need anything else. Now, all the other elements, and not in this row, have incomplete shells, and they will all react with other atoms. You understand? So everything else will react in order to fill their outer shells. Now, there are a few rules about reactivity. The closer the atom is to having a full or empty outer shell, the more reactive it will be. So if it's only got 1 electron in the outer shell, it wants to get rid of it. It's going to be very reactive. If it needs just 1 electron, it's going to be very reactive. Well, if it needs 3 or 4, it's reactive but not as reactive. The closer it is to having a full or empty outer shell, the more reactive it will be. So all of the atoms here, these ones here, are quite reactive. As they've only got 1 electron in the outer shell, they want to get rid of that electron. So they are very reactive. Lithium, sodium, potassium are all very reactive atoms as they've only got 1 electron in the outer shell. For example, lithium has an atomic number of 3, and therefore it's got 3 protons in the nucleus, and it's got 3 electrons. So the first shell's full with 2, then it's got another shell that's got 8 spaces, but it's only got 1 electron. Because you see, it's very nearly empty, only needs to get rid of 1, that's why it's very reactive. Now if you look at its mass number, 6.94, what does that indicate? Well actually, that means it's only got 4 neutrons in there. Now these atoms here are the opposite. They have all got nearly full shells and only require 1 electron to have a full shell. You've got fluorine, chlorine and bromine. These ones have actually got nearly full shells. They only need 1 electron, they only need 1. So as you can see, fluorine has got an atomic number of 9, which means it's got 9 protons and therefore it will have 9 electrons orbiting it. Well, the first shell's got 2, so that's 2 of the electrons. So it's got 7 in the second shell. Well, it needs 8 to fill it. Do you understand? It only needs 1. It only needs 1, so this will be very reactive. It wants to get an electron from somewhere to fill it out. And as you can see, the mass number's 19. Well, that means it's got 10 neutrons. It's not always double. In this case, it's got 10 neutrons in the nucleus. Now, another rule that you'll find is that the further the shell is away from the nucleus, the more reactive the element is. That's why. Which is the more reactive then? Element, lithium or sodium? Which one? Well, it's sodium. Why? Because it's the electron in the outer shell is easy to lose. Because it's further shell out, it's easier to lose this. It's further away from the nucleus. It's got less attractive force. Yeah? So the further you get away from the shells, the easier it is to start to lose these electrons. So it's more reactive. As you go down the periods, the elements, as you can see in the first groups, become more reactive due to outer electrons being further away. So as you go away, it becomes more reactive due to the outer electrons being further away from the nucleus, and there's not a very strong attractive force, so they're easier to lose these. Now, don't forget, all elements are trying to fill their outer shells, and to do this, they can give them, take them, or share them. Give them, take them, or share them. In doing this, they combine to make molecules. And molecules are atoms which are chemically bonded together. That's the important thing. They are chemically bonded together to make them stable. For example, what is a molecule of oxygen? Well, have you noticed? It always says O2. O2. You don't see O as a molecule. That's an atom. A molecule of oxygen is O2. Why? Because an atom of oxygen cannot exist on its own because it does not have a full shell. It's got an atomic number of 8, which means it's only got 6 electrons in the outer shell when it needs 8. The outer shell has got to be... And the outer shell, the outer shell is called the valence shell because this determines how it will combine with other atoms. We used to call this valency, and that's the combining power because the valence shell is the one that you're concerned with. If an atom has 1 electron in the outer valence shell and another atom has 2 electrons missing in the outer shell, then they will combine with a ratio of 2 to 1. Do you understand? So if it's got 1 in the outer shell, it's got a valence of 1. If it's got 2 in the outer shell, it's got a valence of 2. And that's the combined ratio of 2 to 1. So what an oxygen atom does is it shares 2 electrons with another oxygen atom to make an oxygen molecule. This is stable now because both have got full outer shells. As you can see here, that one there, it's got 2 vacancies. It's got 2 extra. Well, if you get 2 of them together and you share 2, as you can see there, that is an oxygen molecule made of 2 atoms, but they've both got full shells because they're sharing those electrons. Do you see how it works? That's why it's O2, H2, N2. Because they've got a valency, they've got a combined paired 2, they have to share electrons. And that's what they're doing, they're sharing. That's why you always see it as H2, N2. It's because two atoms join to form a molecule.